Welcome back. This is Mr. Tipton, and today we are talking about three-dimensional figures. Basically, we're just going to do a quick overview of some different types of figures. Starting off with a prism. These are all prisms here. The prism has two polygon-shaped bases. Okay, right here we have a rectangular prism because the bases are rectangles. Over here we have a triangular prism. And this would be a pentagonal prism over here on the bottom right. Now, these figures, like the prisms, they are named by the base. Okay? And whatever figure is on the bottom doesn't mean that that's the base of it. Just because it's on the bottom doesn't make it the base. The best example of that is up here, the triangular prism. You know, obviously there's a rectangle that's on the bottom of it, but again, that's not the base. The bases are triangles. How do you know what the bases are? Well, the bases of a prism, they're polygons, and they are opposite, parallel, and congruent. Okay, so the triangles on the left and right side are actually the bases because those are the only figures, the only polygons that are opposite, parallel, and congruent. The rectangular prism is kind of unique because it actually has three different pairs of bases. It doesn't really matter because you've got opposite, parallel, and congruent rectangles on the top and the bottom, the left and the right, and the front and back, you know, depending on how you orient it. So I had to redraw my rectangular prism here because it's not letting me write over my image. But let's say that these are the bases, these green sides. Let's say those are the bases of this figure. Okay. The other thing I want you to know is that the part of the prism that is not the bases is called the lateral surface. Okay, so it's all, you know, if the top and the bottom are the bases, then all the rest of it, the right side, the back side, the left side, and the front side would all be the lateral surface. Okay, up here with the triangular, the triangles are the bases, so you've got the rectangle that's on the back is part of the lateral surface. You've got the rectangle that's on the front, and then you have the rectangle that's on the bottom. Okay, in a prism, if it's not a base, it's part of the lateral surface. With the pentagonal prism, pentagons on the top and the bottom, those are the bases. And then we've got rectangles for the other five faces in the front, on the side, on the back right there, back left, and then on the front left there. Oops, there we go. Anyway, so you got your bases and everything else is the lateral surface, and a prism is made up of polygons. Next, I want us to look at a cylinder. Maybe. Yeah, cylinder has circular bases. It's actually very similar to a prism, except the bases are circles. The lateral surface would be a rectangle. If you imagine this to be like a soup can, you know, imagine peeling the label, off of a soup can. What shape would it be? Well, it'd be a rectangle. Okay, if you laid a cylinder out flat, you've got, you know, the top circle and the bottom circle, and then the label would be a rectangle that was straighter than that. Okay, so anyway, that's a cylinder. And also, anytime you take a three-dimensional figure and you lay it out flat like this, it's called a net. The net of a three-dimensional figure is when it's all laid out flat. Alright, so now we have a pyramid. Pyramid is different from a prism because it only has one polygon base. Okay? And the lateral surface, instead of it being rectangles, they're all triangles, and they come to a point. We've got a vertex up here at the top. Sometimes it's called the apex. All right. But again, we have a polygon base, and it's a square or a rectangle down there, and all the lateral surface are triangles. This one right here is called a square pyramid because the base is a square. Again, these figures are named by their bases. Whereas this one is a triangular pyramid. Pyramid. Well, aren't they all triangular? No. No, this one up here is a square pyramid because the base is a square. But you can see down this one, actually all the faces are triangles, which makes it a triangular pyramid. A prism is like a cylinder and a pyramid is like a cone. Again, we have just one base, but this time it's circular. And the lateral surface comes to a point. Now, this is a little different. It is a roundish kind of figure, but if you just took the pointy part, the lateral surface, and tried to lay it out flat, you couldn't really do it because of the way it's rounded. I've been looking up some different ways to describe what the lateral surface of a cone is like, and I've seen people say that, well, you know, inside a cone there's kind of a right triangle, and if you took that right triangle and you spun it all the way around and held the held the right angle part, you held that still right there, then you would get the shape that a cone makes. Kind of like a circle. If you took every point on the circle and you drew a line from the circle to the from the tip, from the vertex, from the apex, what did I say? Vertex, apex. And you did that, you did an infinite number of points all the way around the circle, that you'd create something cone shaped. And yeah, I'm just coloring now. Anyway, kind of hard to describe the lateral surface of that, but I mean it's cone shaped, right? That's not too tough. And the last one we're going to look at is a sphere. A sphere is a perfectly round three-dimensional object. All points in a three-dimensional space the same distance from the center. When we've talked about circles, we talked about how a circle is a figure who has the same, there's an infinite number of points that are the same distance from a single point called the center, and that space is a circle. Alright, same thing for a sphere, but it's three-dimensional. We've got points out there, points all the way down. Okay, perfectly round object. All points in a 3D space the same distance from the center. Alright, so that's just a brief overview of three-dimensional figures. Coming up soon, we will be finding the volume and the surface area of these different figures. That should be loads of fun. Write down your questions, and we'll see you soon.